I feel strongly about exposure assessment, and I feel like more in our field need to know about this and be familiar with the tools and how to use the framework that has been established. So we're we'll focus quite a bit on exposure decision analysis, but especially today, I want to emphasize the fact that that is only a piece of a larger process. I originally I had it so that you could not turn your video on, but I've changed that. I was just clicking stuff, and I think I accidentally clicked that off. So anyway, I'll share a little bit about our process here, our overview for today, and how it will work each week that we do this. If you've seen this on LinkedIn, then you know that I have it spread out over quite a bit of time. So once a month, it'll just be once a month. I believe it's the second Wednesday of each month. We'll cover one topic. In the past, I have tried to cram too much information into a space that's too small. And so that's one reason why I've decided to spread this out over a longer period of time. So we can take our time with it. I'm also calling it a coaching series because I want to answer questions, and especially when we get further on. So especially the last 4 weeks, we'll be using tools, and I will hope that you are able to follow along and practice using them yourselves. I think for me, the one limitation that the AIHA's free course has is that you don't get a chance to ask questions. Now, the course will outdo this coaching series in a lot of ways. It will cover more content. What I decided that I can offer is a living, breathing person that you can ask questions to in real time and hopefully get answers in real time. So, although this will be, I hopefully you saw, I am recording this so that we have it as future reference. So today we'll cover exposure assessment. We'll talk about the big picture, and then we'll talk a little bit about exposure decision analysis, but we'll really lay a little bit of groundwork for that. That is going to happen in the first 30 minutes, the things that I show in just a moment, and the last 30 minutes will be open for discussion and questions, and that can go, that is up to you. We will go in whatever direction you would like to go there. Week two, we'll dive into exposure decision analysis, talk about it itself as well as the rule of thumb. So there's a way that you can estimate your. Now we're not getting super fancy with our rule of thumb, but our exposure rating and control category. So ERCC is exposure rating and control category. You can estimate that without fancy tools or even a calculator. You could probably do it in your head. So we'll talk about how to do that when we get to that point in week two. Week three, we will use the tool. So we'll start with a web-based tool called ExpoStats. We'll also take a look at a couple of other options. So there's IHDA. It's a piece of software that you install on your computer. And there's also an Excel spreadsheet that it's like IHStat, but it has the Bayesian statistics built into it. So we'll take a look at those tools, and that's why it's a coaching series. And what's spread out is you'll have the chance to download those or open up the web page and follow along. And if you're having issues, then it's a chance for us to chat about it. In week four, we'll talk about interpreting those results. So the computer will do the heavy lifting, but we have to make sense of the data and the information that it provides us. So week four will be focused on that. And then week five, we'll talk about how you use that information to identify the types of controls that you're going to recommend and implement. So today we'll cover our objectives for this week. We're going to do an overview of exposure assessment, the process. We'll review some statistics. We're not going to get deep. Like I said, it's only 30 minutes, so before we do Q&A. So nothing too crazy, but just some very basic ideas with statistics that are important for interpreting and understanding the output from our decision analysis. And then I'm going to highlight some free resources. There are two resources from AIHA. We'll review and then open it up for questions, comments, etc. And ask me anything, an AMA. Ask Rustin anything that you want. At the end of this session, you'll be able to summarize 3 of the steps of the exposure assessment framework or process, explain what the 95% upper tolerance limit is. That's a big goal for today, is for you to understand what that is and to be able to explain it. Discuss 2 free resources and be able to share those with a friend if you'd like, for exposure decision analysis. So let's talk about exposure assessment. The process itself has 6 steps. It's I think of it as a framework or a process. You're probably familiar with Plan, Do, Check, Act or similar cycles, you could say, models. There's also ARIC that we talk about a lot, and ARIC fits well with the exposure assessment process. I'm going to add 3 C's there. CCC, people add different C's. Confirm. Well, you see one of them there after control. Confirm and communicate. Confirm and communicate. So this is another way of framing one of these cycles. It's a similar idea, just a different way of framing it, of approaching it. So keep that in mind. You can see that there is a cycle. So we do circle back here and start the process over again once we've completed. When we say start, we're meaning that we come up with a strategy. We'll talk about these bolded items, steps 1 through 3 and 6, in a little bit more detail today. Steps 4 and 5, I'm not going to really dive into. I had to cut some things. I didn't want to try and cover too much. So we'll cover 4 of these steps. Start is where we establish our strategy. We'll talk about basic characterization, and then the actual exposure assessment. When a lot of people think of industrial hygiene, they think of this piece, this one piece, and it is an important piece, and it's a big step. This is where we actually take the measurement. We do sampling. That's what a lot of people think about, and it's very important, but it's one piece in this whole process. And to be honest, there is a lot crammed into this part, because we're also going to use our decision analysis and our tools to make a judgment about where our exposure risk lies. So it is very important. It's not the whole process, though. We're zoomed out here. We are gonna zoom in to just a piece of this after we get going and in the following weeks. The piece that's one of the pieces that tends to be difficult for people, and so that's why we do it. And then finally, we'll talk about controls. So we have control here when an exposure is deemed unacceptable, but there are other times where we're going to want to control. So regardless of our outcome, there's a good chance we're going to be implementing controls. We're going to be recommending mitigation strategies, and then we repeat our cycle. So we're going to confirm. That means we're going to monitor again, take samples again to make sure that, yes, our controls are successful. But a thing I want to emphasize is that we're going to let the process and the data drive our decisions. It's a data-driven approach, and not all data is quantitative. There are a lot of data that are qualitative, and we'll highlight that a little bit in these first 2 steps, where we actually do a qualitative assessment of our exposure before we do anything quantitative. So that's part of our process. Now, we tend to give more weight to the quantitative data, but the qualitative is still there, and it's still important. So this is the AIHA framework just says start, and I'm throwing on the extra information there. So we're establishing our exposure assessment strategy. We're going to identify what the goals are. So it's likely to evaluate an exposure to X, Y, or Z to this specific group of workers or to this community. We're also going to, as part of that, we're going to want to be able to prescribe a management plan. Like I mentioned, the controls. We need to determine what our decisions criteria is or decision statistic. We're going to talk about what that is once we have it. I don't see a reason to use something else. We're going to talk about what that's going to be. We're going to have a written program. We're going to want to make sure we outline the scope. The scope is like a fence we draw around our project to make sure it doesn't. You've probably experienced project creep where the project starts to balloon. We're going to draw a fence and say, no, this is what we're going to do, and that's all. We're going to look at the type of method we're going to use to sample. I'm rephrasing that bullet point. We're going to sample. We need to determine what method we're going to use. We also, it's not on this list, but, and I should have had it on here, we need to decide which exposure limit we're going to use. Are we using the PEL? Are we using the TLV? Are we using the REL? Are we using something else? Is there one that even exists? Sometimes there's one that doesn't even exist. So what are we going to use? Maybe one from a different country. Maybe we're doing some exposure banding. It starts to get difficult when you're in that territory where you don't have an established exposure limit. And it's tough to use the tools we're going to talk about later in those cases where you're doing control banding or exposure banding. So our focus mostly is going to be on these health-based exposure limits that we have access to. We're going to, so I say basic, they say basic characterization. I say we're gathering information. So we want to understand what's going on. Imagine, I want you to put yourself in, this should be easy for you all because you do this maybe every day, but you've been asked to assess an exposure. Someone is complaining about headaches or irritation, or the OSHA or the MSHA inspector is telling you, hey, what is your exposure at for this group, for this exposure, this contaminant. For one reason or another, you've been asked to sample, to perform an exposure assessment. Think through the types of information you want to gather before you start. Now, if it's something that you deal with every day, you've probably already done this. You don't need to do much of it because you've laid that groundwork. But imagine it's something new that you've never sampled before. You've never assessed this thing before. What what how are you going to figure out what to do, how to do it, who are you going to talk to? So you're going to figure out what sort of tasks are performed, what are the jobs, what are the SOPs, what are the processes, what chemicals or other materials are involved with this, what controls do you already have in place. You're going to know, you're going to want to, so when I say materials used, you're going to look for the SDS. We're going to look for, we may be looking in the NIOSH Pocket Guide. We're going to look at PubChem. We're going to be gathering toxicological data. We're going to try and wrap our head around this thing as best we can. Again, this is assuming it's something you've never assessed before. It's your first time. You're gathering information to make sure you have a decent understanding of what's going on and what the risks are. Throughout this process, you'll also be gathering information so that you can establish what we call similar exposure groups. So all of this is a qualitative assessment. We're collecting, a lot of this is qualitative data, and it's still important throughout the entire process. I'm going to emphasize quantitative data later. I want to make sure it's clear that the qualitative data is very important as well, and sometimes overrules or overrides what the quantitative data show. And we'll get into that later. But often a similar exposure group is a crew. So the maintenance crew, the operations crew, production line, that's typical. That's not always the way it works out, but that's a common grouping is by crew. Sometimes you'll have SEGs that are within certain crews. So half the crew always does this job, the other half does that job. Well, then you need two SEGs for that. So sometimes that's the case, but often you're going to have a crew that's all doing the same thing. That is an SEG. And sometimes you have SEGs that are very large because you have multiple crews that all do the same job. They just may be on rotating shifts. It might be in different parts of the facility or at the site, but their exposure you anticipate is similar. And I don't want to dive too much more into that. But one thing I want to say is if you don't use similar exposure groups, I highly recommend it. It allows us to extend our results for a small group of individuals who actually get sampled to the group. We let those samples represent the exposures for the group because we can't sample everyone, and we'll talk about that a little bit later. Then we do our actual exposure assessment. Like I said, most people think of when they think of industrial hygiene, they think of this, taking the measurement, taking samples, because that's where people see us, where we're at least maybe more actively. We're out, we're interacting with supervisors, with frontline workers, with management. We're sampling, we're making observations. So people think about that. And again, it's a huge part, but it's only one part of the process. So we're going to gather data. And now we're talking about quantitative sampling data that will help us make a judgment. Our judgment is going to be data driven, quantitative and qualitative, but we want the evidence to drive what we decide. And we'll talk about these in more detail later, but we're going to come up with a rating for our exposure. We're going to determine what its uncertainty is. So if there's a lot of uncertainty associated with an exposure, we may need to do more monitoring. We will want to do more monitoring because we don't know. That's the idea with uncertainty is we're not sure. We're not very confident about where the real exposures are, what they actually are. So, and I'll talk about that in a little bit more detail in just a minute. Also, based on the toxicity and that judgment helps us prioritize controls based on these things, the level of the exposure, the severity of the health effects. You can see these are related here, our exposure rating, and then uncertainty. So these are all related there. That's going to help us prioritize which controls we use. Yes, based on the level, but we've got to consider the bigger picture when we make that judgment. And the last step, this is step number 6 from their process. I skipped over 4 and 5, but is determining what controls to use. Now, we're going to talk about this table in more detail later, but this is one reason why I really, really like AIHA's approach and their framework for both exposure assessment and exposure decision analysis is it makes it easy. And I don't mean that it doesn't take work, but when I make a determination, make a judgment on where an exposure rating should be, I have confidence that I'm established on firm footing, and I don't feel any uncertainty about my recommendations because I know I followed the process, I've used the tools, and this is as good as anyone could get in this situation, given the circumstances. So I really like it because, like I said, it makes me feel confident about what I'm recommending and the controls that we're going to implement. So we're going to look at this later, but you can see there's a sort of spectrum here where we are adding more and more controls the further down on this table. But in terms of rating, the rating is going up. We have a higher exposure, so we're going to add more controls to our recommendation and to our management plan. So a quick review of statistics, and I'm going to ask more questions here. So feel free to put in the chat or to unmute and mention anything when I ask any questions. So this question is not only for why statistics, but why have an exposure assessment process, exposure decision analysis? Why have any of that I want to help highlight the reason why with a couple of questions. So whether it's unmuting or in the chat, however you want to do this, but what is going to happen if we underestimate exposures to our workers?
Hi, Rustin. This is Bharat.
Hey,
Yeah, so if we underestimate, there will be more chances of realistic exposure, and the consequences could be worst. Maybe irritation. We don't know. We cannot scale up, but we can say that there could be something wrong could happen. Health effects, because already you already mentioned the data is already having some worst scenarios. So we can think that, and if we underestimate the exposures, sure, the exposure is confirmed, and we can see the symptoms and signs of deterioration of health or anything else. I'm just telling in a broad way, in a generic
mm,
way rather than specific way. Thank you.
perfect. Yeah, no, perfect. You're exactly right. Uh, okay, good. And there are some chats there. So I'll say Kieran and Catherine. Yes, and so that's exactly right. There's a good chance, we'll speak in terms of chances or probabilities, that we are going to yes, exactly. Thank you, Ryan. Overexpose. And I think that's the Ryan Corpus that I know. It's good to see you, Ryan. So there's a good chance that we'll have overexposure. Our workers will be overexposed as occupational environmental well, let's say EHS professionals. As EHS professionals, that's what we are all about, is preventing that. So that one's pretty obvious, I think, to all of us, in that it's our job to make sure that doesn't happen. But on the flip side of that, what happens if we overestimate? So let's say we've been overly cautious, overly conservative in our approach, and we overestimate exposures compared to where they really are. So thank you. Oh, well, I'll wait in case anyone wants to unmute. Um,
Yeah, maybe spending a lot of money on controls could be PPE, and overburden of PPE on the workers, maybe, and lots of money spending on the engineering controls and unnecessary administrative controls, everything.
Perfect. Good. Thank you. And the chat is great as well. So Nicole says risk of over engineering a process, waste of resources and money. Catherine says spend unnecessary amounts of time, resources, and money. And to me, all of those start with dollar signs. Time, resources, and money. Kieran says more capital spending and burden on workers. Good. Ryan says too much paperwork and waste of resources. Good. Good. So the idea here is that we didn't need to invest all this time, money, and resource into this control. We could have invested it in something else that would have been of greater benefit. That's what I would call return on investment. So we're going to have a low return on investment if we're overestimating exposures. We're not going to be as effective as we could be. So, yes, we want to be protective of our workers' health. At the same time, we want to be as close as we can to the real number, the real exposure as possible. And that's what this whole process and the statistics help us to do, is to get as close as possible to what the real number is. So let's talk about that. Also causing unnecessary concerns. Yeah, that's a good point. You get people who start freaking out, and they don't need to. It's another stressor. They don't need more stress. None of us, well, most of us don't need any more stress in our life. Okay, so that review of statistics. If you've ever heard of a normal distribution or a bell curve, I want to talk about that briefly. So it's this nice looking symmetrical curve that you see when you're plotting a distribution, when plotting frequency. So this is for SAT scores. I just grabbed this somewhere. The idea here is that you can split the data right down the middle, and you've got 50% on one side, 50% on the other. You know, a nice, neat split. Unfortunately, with environmental samples and industrial hygiene included, that's not how it works. We don't have bell curves, at least for samples. You know, for the heights of employees, for the weights of employees, you probably have a bell curve. But for environmental exposure, that's not usually what we've got. We've usually got a log normal distribution. So instead of that nice symmetrical curve, we have something like this. This would be called a right skew curve. So you can see, you know, and this is not necessarily a perfect log normal distribution, but you can see most of our samples will be clumped together over here close to zero, which in a way is a good thing, right? We want our samples, we want our exposures to be close to zero. So most of them will be closer to zero than not. The challenge comes in using statistics because we can't use traditional statistics if our data are distributed this way. We can't, you know, we don't have a nice symmetrical divide. So if we were to take the median, we could divide it, but you see, you know, we've got a curve that looks like that and something that looks like that. And that's not symmetrical, and it throws out all the normal statistics that we could use. What you also see is that we sometimes, every once in a while, will have exposures that are way over here on the tail where we have really high exposures. We're concerned about that. We don't like that. We don't want that. So it adds some challenges. Uh, we'll we're not gonna dive into any of these. The geometric mean is different from the arithmetic mean, a regular average. And the geometric standard deviation is different from a regular standard deviation. The point I want to make here is that these measures are designed for this type of graph. So we can't use the regular average. We can't use a regular standard deviation. We have to use these. And to answer that question, it would be the B here. That would be the geometric mean. So in addition to those, like an average or a standard deviation, we can't use other regular statistics, including the 95th percentile. If we're trying to estimate where that is, we have to use a different approach. It's not quite as straightforward as it is with a normal bell curve distribution. So so that's the main idea there. We're going to look at another idea and then combine the two here. So, and I'm going to go over 30 minutes in classical fashion. I'm going to talk too much. Um, I'll try, I'll leave hopefully 15 to 20 minutes for questions, and I have time after the top of the hour as well. But we looked at distributions. We're going to look at population versus sample, and then we're going to, excuse me, we're going to combine the two ideas together. A population in our situation here would be every exposure of every person. So my background is mining. Let me just give you an example. The first mine that I worked at had about 1,000 employees. Not all of those people worked in the mine or production or refining processing facilities. So not everyone had serious health exposures, but let's say there's a subset of 500. So I have 500 people who get exposed to something, noise, dust. You know, those are the two big ones in mining. When you make big rocks into little rocks, it's noisy. So let's say we have 500 people who are exposed every time they come to work to one of those two things. If I had population level data or population level statistics, I would have 500 samples for noise and dust every single day. So 24/7, 365 days a year, I would have a sample. but we all know that that doesn't happen. That never happens in industrial hygiene sampling. We don't have enough time. We don't have enough money. We can't do that. So we take a small, we call it a sample. I'm talking about a sample in terms of statistics, not in terms of measuring an exposure, but we take a small subset of those exposures that we actually measure, and we call that a sample. That sample is going to help us try and figure out what those 500 exposures were every day, but we don't have that. In my experience, you would be lucky to have 500 period for a year at a mine site. That's probably not going to happen. It's going to be lower than that probably. But we're talking, when I say population, talking about 500 every day of the year, and we don't have that. We might have 500 for just total for the year. So let's take a look at what that looks like. Let's say we have one worker who works 5 days a week and 50 weeks out of the year. So this person gets 2 weeks off. Hopefully, everyone gets more than 2 weeks of vacation, but this person, we're going to assume, gets 2 weeks off, 2 weeks of vacation. That's 250 days that this person is exposed. Let's say that, I don't know, this worker is really helpful and doesn't mind being sampled. And so we get 5 samples throughout the year on this one worker. What I've done here is I used Excel to randomly produce exposures for this worker using a log normal distribution, and every blue dot, so there should be 250 blue dots on the chart. And the ones that are circled in red, I randomly sampled in Excel. So I randomly pulled those ones from Excel, and those represent the 5 samples that we actually took. So you can see throughout the year, there are a lot more exposures than just the 5. And some of them were much higher than those 5. If we calculate the 95th percentile for our sample, we'll get something like, I don't know what that is, 0.45 parts per million. But if we knew what every single exposure was, we would know that actually it's around zero point 0.7. It's around 0.7, which is 62% higher than what our sample 95th percentile was. I'm just using this as an example. So we're off by a lot. And if we think that this is where we're at, then we are underestimating. And like we said before, we don't want to overestimate. We don't want to think we're way up here. We want to try and get as close to this number, the real 95th percentile as possible. So that's where our statistics come in. And I'm going to go back actually. What I want to emphasize here is this right here is one way of describing what I am going to call the 95% UTL. So that's one way of describing it, is the population 95th percentile. There are other ways that you'll see AIHA, they describe it, and other people describe it in different ways. That's one way of describing it. And so when I say in this little series, the 95% UTL, I'm talking about that number right there, the real or the true, so you might hear those words too, 95th percentile. And sometimes some people just say the 95th percentile, but they mean that one. They don't mean that one. They mean the population level 95th percentile. So why would we be interested in this number, the 95% UTL? Well, now like I mentioned, the tools do all the heavy lifting. Is kind of like a Ferrari, and when it comes to statistics, and we don't have to understand how the engine under the hood works. We just have to know how to move the steering wheel and shift. And I don't know if a Ferrari is manual or standard, but regardless, There might be a little bit involved to drive, to operate the car, but you don't have to understand how it works. You just need to know how to operate it. And we'll talk about that. That's one of the big goals of this coaching series is for you to be able to use those tools. So again, the what's under the hood is more complicated than, I don't understand everything under the hood, but you don't have to know what's going on. You just need to understand that if you follow the process and you use the tools correctly, you can say, based on your results, and if you continue the cycle, let's say you have high exposures, you continue the cycle, you bring them down, you will be able to say that I'm 95% confident that 95% of my exposures are below our exposure limit. That's what we want to say. That's the whole goal of not just us, but the exposure assessment process and the cycle, the framework is we want to be able to say that our workers, so 95% of the time, our workers are safe. Their exposures are below the exposure limit. That's what we can say if we follow the cycle, the process, and we use the tools correctly, and we do good at controlling exposures. That is the goal. We can't protect everyone every single time, but we can protect most people. We should be able to protect 95% of people with 95% confidence. So again, you don't have to understand how we come up with those numbers exactly. Just know that if you follow the process, you'll be able to say that. And so the tools are going to help us figure out what this line is. This is just another, this is flip, that other, it's turning this one on its side. So if we were to rotate this 90 degrees to the right, then you see now it's going this way instead of up. And so this is our sample, 95th percentile. This is our population, 95th percentile, or our 95% upper tolerance limit. We're very interested in where this line is. So the tools help us understand where that line is. And if it's below our exposure limit, we are very happy. We're doing our job in protecting workers. Okay, so let's talk about the free resources, and then I think maybe we will have 20 minutes for questions and to discuss anything. Like I mentioned, in moving forward, there will be more hands-on and practice-based things that we do. The rule of thumb, using the tools, interpreting and identifying controls. So let's talk about the free resources. I'm not the only one who is giving out information for free. AIHA has two courses I'm going to, or well, a course and a registry I'll talk about. But I just want to say about those courses and this process. Why should we do it? It improves your decision making. It handles uncertainty very well. It adapts to new information. So if you take more samples, you include those in the process, and it gives you, it'll increase your certainty. Hopefully, it will your exposures will be coming down. They may or may not, but it adapts to that new information. And like I mentioned before, it protects workers. I also mentioned that I'm a huge fan of the process because when the tool gives me a rating, let's say I'm at category 3, then I know, well, I need to look at these sorts of controls. I'm going to look at everything from 3 up on this table. And for me, that's very helpful. I can have confidence. And if anyone asks questions about why are you recommending this or that, I can say, well, I followed this process and this was the decision. Using these tools, using best practices, this is the decision. So it makes that part easy. So AIHA has a 9-hour video course that is free. You need to create an account with AIHA, but you do not have to be a member. You do not have to pay anything to start this course. It's called Making Accurate Exposure Risk Decisions. I highly recommend it. As soon as I found out about it, so I did, I've learned a lot since it's been a couple of years since I took it. Uh, like I said, very well done. There are parts where you may be able to watch fast or kind of skip over. Not every minute is amazing, but overall, I think it was very well put together. It does have practice questions included. They do ask that you complete a course evaluation before getting your certificate, but it's a great option for CEUs if you need continuing education. And anyway, I like I said, I highly recommend it. 9 hours. If you can watch at 2x, like I often do, then you can complete it in 4.5. Or, some people go even faster. I don't often go above 2x, but I guess it depends on the speed of the person speaking. Also, they have this registry exam, so you can become what they call a registered EDA specialist. It's a two-section exam. I get before I talk about that. I did look at this more recently. It's up to 685, something like that. It was as of a few weeks ago. So not a ton of people. I'd like to see more people who have taken the course and completed the exam. But I would. This is the way I call. I they have a long name for it. I feel like it's too long. I would just call it registered EDA specialist. But anyway, the exam has two sections, a 35 conceptual question exam and a 33 applied question exam. In my experience, this one was much easier because you plug the numbers into the tool and then you interpret. For me, that was very easy. The conceptual was a little bit harder. I still managed to pass, but anyway, the practice questions from the course will be very helpful for preparing for this exam. And the course itself, obviously, they're meant to go together. That is free as well. You'll need an account, but you don't have to be a member. So we talked about the exposure assessment process. There are several steps. I highlighted these three, and then controlling. We are going to, for the next, over the next uh, the next 4 sessions, we're going to focus very heavily on the exposure assessment aspect of it, especially the exposure decision analysis. So what we cover will be sort of the essence of that 9-hour video course, but condensed into a couple of hours, basically. We did a review of statistics. So we looked at the 95th percentile for a log normal uh, distribution, and then we looked at population versus a sample. And we're interested in this, the 95th percentile for the population of a log normally distributed data set. That's what I call the 95% UTL. We also looked at free resources, and I do plan on making this recording available. I have not set up the channel for it yet, but I will do that, and I'll make sure it's available on LinkedIn, so anyone who's seen me there will be able to see it. So let's let's open it up to questions, whether it's in the chat, if you would like to unmute yourself. Either way, um, let's talk. And like I mentioned, future sessions will have some more hands-on where you'll get a chance to practice using tools and interpreting results. So William asks, any free resources to help with statistics for the CIH exam? Great question, William. So the health risk analysis, or I say health risk analysis, that's what BGC calls that portion of the exam, where some of that would fit, some of it would fit. In terms of free resources, this course, the AIHA video course, and I suppose this coaching series will help some. It won't help with some of the more obscure statistics, like the LCL equation on the sheet, or the like a t-test, for example. But uh, I would recommend that is not showing up very well. Khan Academy. Khan Academy. They have a lot of great videos. I haven't seen their stats videos specifically, but I imagine if they have anything that it's well explained. So I would focus on uh basic things. So the exam has you focus on the 90% confidence interval, the 95% upper confidence limit. So look for videos from Khan on that, or just anything online on how to calculate that. Those two are fairly straightforward. There's some others that are more challenging. But so you should be able to fill in a lot of gaps with Khan, with the AIJ course, with this coaching series. There'll still be a few gaps for some of the more obscure things. Um, in terms of free, I can't think of others though. Okay, Ebenezer says an expert in the mine. If an SEG, say drill, offsider, or sampler has an exposure rating of 4 to noise or dust, what engineering controls will be best to implement? You're welcome, William. Okay, great question. Yeah, so good questions here. So let's come back to our table. I'm going to go to the full table. Whoops, the large table here. Great question. So we're going to get into this. We're going to dive into it. But like I said, the question is question. It's an ask me anything. Ask me anything. So that is fair game. So you have say you have drillers and they have an exposure rating of 4. Great question. So this is going to be the 30 to 60-second version from Rustin. But when I see this say implement the hierarchy of controls, you see that we've done some things, and a lot of this actually is administrative. So if you look at the table, a lot of these, category 1 through 3 is focused on administrative controls. I would consider monitoring administrative, any type of monitoring. I would consider that administrative work practice controls. That sounds administrative to me. uh, Hazard communication sounds administrative. A lot of administrative, actually, to be honest, in categories 1 through 3. Once we hit category 4, that's when we're going to add in engineering and our PPE. So obviously, we want to prioritize engineering, but we may have to use PPE as well. So this, when it talks about respirator protection factor, that makes me think that they're they're assuming we're going to do both of these things. I think that's the idea. And so for drillers, you're going to want to look at the seal in the cabin, the enclosed. Well, I'm assuming this is, I guess I don't know if this is a large piece of equipment that has an enclosed cabin. Then you'll look at the seal. You'll look at the air cabin filter. Now I guess that's administrative, but you want to make sure that's cleaned, that you have a good filter in there. If you don't have an enclosure, then I would try to enclose the cabin. And let's say you're not drilling in a large piece of equipment. This is a jackleg drill underground. Then that gets harder. That gets a lot harder. Noise and dust. Yes, exactly. Those are the number 1 and 2 exposures in mining. Um, in that case, when you're looking at, if you say you have jackleg drills, manually operated drills, that gets tough. So in terms of engineering, you're going to want to look at new drills or modified drills. So some people have looked at ways of muffling because those are air powered. I guess this is more than the 60-second version from Ruston, but air powered, because the jackleg is powered by air. There are ways that you can muffle the air that's exhausted out of it. You could also look at the way that the steel is, maybe banging around inside the drill. Look at ways to minimize that or to muffle it as well, to dampen that vibration. Um, yeah, beyond that, then the rest is PPE. So I'm thinking of noise there for dust. For dust, you would increase ventilation if you're underground and manually drilling. Try and increase ventilation. You may want to have a mister or some water sprayed somehow to. Now, if I'm remembering right, those drills, they're connected to water lines as well. So you should have water around, I hope. Um, More water, more air, for engineering, and if you have to, then go to PPE. So that's my okay. You asked engineering, so I guess yeah, I did highlight that mostly. But other questions or follow-up questions? Was the frequency of sampling for an SEG having an exposure rating of 4 as compared to another rated 1? Can I spread an SEG with an exposure rating 1 over 3 years? Great question. So there, and yeah, getting ahead a little bit, but that's okay. I said ask me anything, so that's on me. Okay, Ryan. Thanks for coming. Great to see you. See you virtually. So let me read your question again here. You have one that an SEG that's at 4 and another that is at 1. If you're at 1, so let's start with 1. That one's a little bit easier. Well, again, we're getting a little bit ahead, but that's okay. So we'll also really what is going to drive this is that category 4 percentage. So even though the rating is category 1, you look at the probability of category 4. If it is greater than 5%, then we're still going to monitor, but the frequency is going to depend on different things. Let's assume that you are on site, every day or 5 days a week, whatever. Then maybe you still do quarterly, but maybe not. Maybe not. With a category 1, if you have a low, if the percentage is low in category 4, you could spread that out. Yeah, maybe it's once a year. Again, keep in mind if anything changes, so I'm using the delta symbol there. If anything significant changes with the process, with materials, with equipment, etc., the way the work is done, then we may have to reevaluate and start the process over again. Assuming things just stay the same, then you could spread that out. I don't know about can I spread an SEG with an exposure ring over 3 years? Because I'm not sure what you mean exactly by that, but I'd say I'd at least try and do once a year. Again, that's assuming no change for the category 1. If something changes, then you're gonna have to sample again to see. But for category 4, that's a tougher decision, but it kind of depends on how accessible the SEG is. If you're able to, if I would say at least quarterly, but you may look at doing it more than that. It kind of depends on different things. So, the accessibility, what is the work process? Are they doing? So I'm like with mining, if if it this is a they're sinking shaft in a shaft mine, if they're actively mining, I'm more interested in sampling. But if they're not doing that, then I'm okay waiting because that was my biggest concern is when they're actively mining, I'm more concerned. So it kind of depends on the cycle of the process and how that works. But just as a rule of thumb, I would try to do at least quarterly. That's what I would shoot for. And Catherine says, what happens when you have variability with your data? For example, I do noise monitoring for geologists exposed to noise. There's different methods of drilling that can impact the overall sound levels. Great question. So, yeah, stuff that we're going to get into, and maybe I should have not spread out the series so much. But great question. So, so that we could get to some of these sooner. I guess I'll take a quick poll. I could handle every other week. I'm just curious if I'm not going to do an actual poll, but if you could put in the chat, would you be interested in doing every other week for this? I try to keep it to an hour so it doesn't take too much time for anybody. But anyway, let me know if that's feasible or if you would prefer the once a month. I did once a month, but um, okay. anyone to the contrary, let me know as well. Okay, all right. So yeah, we'll do it every other week. That way we can get through this more quickly. So to Catherine's question, that's a great question. And sometimes you have an SEG, you have multiple SEGs within a crew, and sometimes that's not because it's different people. Sometimes it's because of what they're doing. It's task based rather than crew or person based. So it would be fine for you to have an SEG within. So you have your geo, let's say you have your geo SEG, and you have two, they're the same people, but you have different drilling methods of drilling. So you have type number one and type number two or whatever. I don't know what you call them, but you kind of you have to use your that yeah you have to use that qualitative assessment to help guide that process. So again, I don't have a one size fits all answer here, but if you're qualitative, they call it basic characterization. But it sounds like you have some good evidence to suggest that maybe these should be broken out into two groups. I would, you'll still have the data for each group, and you'll still know that they could go together or they could be separated out. What I would suggest is that you run, and we'll talk about this in a couple weeks, but you run your exposure decision analysis with the two separately, and then you could run it combined. And we'll talk about this, but you'll want to look at, you mentioned variability, and that's exactly the right question. So look at the geometric standard deviation. So the rule of thumb from AIHA is if it's greater than 4, then you need to think about breaking them out. So let's say you did it combined, you combined it all, and it was greater than 4. You should think about breaking them out. But for you, that would be just another piece of evidence to say, yes, break these out into different groups. Maybe you run them together and it's a really low standard deviation. Then maybe you could keep them together, but the data, the quantitative analysis helps us, but it's not the only thing. So your experience is definitely a major factor in that decision. At least in the beginning, you could play around with, it's not that you could play around with the data later as well, but I would suggest playing around with it a little bit and see what does my standard deviation look like if I do them separately, do them together, what do I get? And use that to help inform your decision. But sounds like you already have a good idea there. Oh, you're welcome, William. Yeah. So GSD not yes. So for the SEG, we're using lots of acronyms. We use lots of acronyms in industrial hygiene, but for the SEG, you're going to look at the and some similar letters here, but the standard deviation. That's going to help drive how you categorize those groups. You also can look at the quantile plot. We'll talk about that later. That one is not it's kind of subjective because you're just looking at a figure, but it can be helpful. That's from Expo Stats, from IHDA. They do have or maybe it's not that actually. Maybe it's the spreadsheet IHStat. I think it's the Bayesian IHStat has a value, a metric that tells you how well the data fit a log normal distribution. So this is kind of telling you that, but IHStat has another metric, and we'll take a look at that. Another number that you can compare with a reference level to determine whether you should keep your SEGs the same. When it comes to controls, then yes, you're going to look at the 95% UTL. So what am I supposed to do about well, when it comes to the rating and the control, that the 95% UTL is 100% going to drive that, be the biggest piece of evidence that you use. Yeah, good questions. Other questions? Awesome. Yeah, I hear crickets. So, you're welcome. You're welcome. Thank you all for coming. I really appreciate it. Lots of great participation and good questions. That helps a lot. So, thank you. And like we said, we'll change it to every other week. So, in a couple weeks, we'll do it again.
Thanks, Rustin. Have a good night. Bye.
Thank you. You too.